Welcome to Math with Doug. This is Mocha. So no, it's not Math with Dog, it's Math with Doug. And we are doing some geometry, a lot of angles this week. This dog is going to behave very well for a whole hour while I talk about angles. Lie down. Stay. My shirt's sticking to me now because of static electricity from her fur. This shirt is a Spain national team jersey. And with that, let's get into the geometry. Yes, it is geometry. It's all about angles. We're doing a lot of stuff with angles today. So let's talk about some of the words. This is a review. I know that. We've been talking about geometry for a couple of weeks now. So a lot of this is a bit of a review about an angle. What is an angle? When you have two rays or line segments with the same vertex, that is an angle. What is a degree? A degree is the unit of measurement of angles. So the degree is 360th of a circle, and we use that to measure our angles and to draw them. And the vertex, of course, the vertex is the intersection of two or more segments, lines, or rays. So that was a review, and now I can erase that and make room to draw some angles, and we can get into some more interesting stuff. Okay, so types of angles. Let's get into the types of angles. The straight angle, that's an easy one, but it's also weird because when we start with the straight angle, it's almost as if we haven't gotten into the angles yet. A line, it's hard to draw with your hand in the way, but a line can be a straight angle, but it's hard to see that unless you see where there's a vertex. So if I put a vertex here, I can say, well, there you go, there's a straight angle. A straight angle is an angle that's so wide that it ends up forming a straight line. It's also 180 degrees if we measure it. And of course, every 180 degree angle, if I really wanted to, I could draw the angle going around this way or going around that way. So I can see a second 180 degree angle underneath it. That's interesting. And it's interesting because if we add these two together, well, what would we have? We'd have a circle. And you can sort of see that in the end, I kind of drew a circle there. These arc symbols for my angles are parts of a circle. Okay, so there's a straight angle. I'm not going to do too much with straight angles, but you have to know they exist. Because every now and then you'll be dealing with all sorts of other angles of different measurements, and suddenly they'll throw a straight angle at you and you have to be able to handle it. Okay, what's the next one? Where's my eraser cloth? Okay, one of the most common angles that we find ourselves talking about a lot is the 90-degree angle. So I'm going to start by drawing a line segment. And of course, there are different ways to draw a 90-degree angle. We can draw one with a protractor, and we're going to get into the protractor quite a bit today. But we also realize that an awful lot of the objects that we deal with in everyday life have 90-degree angles in them, like the corners of a lot of furniture, etc. Like a desk you might actually be doing your homework on right now. Like the corners of this ruler, there's two 90-degree angles right there. And even this little thing, which is a magnet, there are 90-degree angles there. You find that 90-degree angles all over the place. So if I draw a line that's perpendicular to this one, and I'm sort of doing that without a protractor right now, I am drawing a 90-degree angle, which I can show the usual way with an arc and description of the angular measurement, but I can also put this little square that shows there's a 90-degree angle there. If you don't have a protractor, you could find an awful lot of those objects that have 90-degree angles in them and sort of trace one, and you would get a very nice 90-degree angle that way, like the edge of this piece of paper. So if I just draw my chalk right at the edge there, so that some of it goes on the paper, well, I just drew quite a nice little 90-degree angle there. So without having to get into the protractor too much, we're even able to do that. 90-degree angles are interesting and they're useful, and we're going to see them a lot when we do all sorts of geometry. They are part of the right triangle. We use them in the complementary rule, which we will get into as well. 90-degree angles happen a lot. Now, let's get into some other ones though. We want more variety. We have the straight angle, we have the 90-degree angle. What about all those other angles that are in between? So all the angles that I could fit in here, I'm not erasing the angle itself, and I'm erasing these things I use to label and measure it. All the angles that I could draw that would fit inside this are angles that are between 0 degrees and 90 degrees, which makes sense. And those are called acute angles. Acute. So if I decide I want to draw a straight line like this, I can say here's an angle, and I know it's an acute angle because I know it's smaller than the 90-degree angle. Therefore, I have drawn an acute angle. But I can also just get a ruler, draw a baseline, one of the lines for my angle, decide I'm going to say that's my vertex, and then I can draw anything that's less than 90 degrees, and it's kind of easy to do that by eye, just by feel. So I can draw this one. I'm getting dangerously close to 90 degrees, but I know it's less than 90 degrees, and I'm able to tell that by eye. But of course, we don't want to just be doing things by eye. We also want to be able to draw an angle of exactly the size we wish, and be able to label it, and be able to read an angle and know its measure. So let's draw some more acute angles. So there's one. And of course, here's another thing about angles, is that I can draw an angle so that it opens up like this, but I can also draw an angle so that it opens downwards. Now, it might seem confusing sometimes. Wait, is he talking about this angle? Or is he talking about this one? And that it can be confusing. The arc becomes useful because it draws our attention and makes us realize, okay, the angle we're talking about is this one here. And that isn't an acute angle. It's pointing a different way than this one was, but it's less than 90 degrees. That I can sort of tell by eye, but I can also measure it to make sure. Okay, what about angles that are greater than 90 degrees? I'll draw another baseline. Make sure that shows okay. That's already crooked, so let's start over. Oh, what a messy angle. Okay, I'm gonna have to do better with my ruler. Now this ruler does have magnets on it, but the chalkboard wall is not magnetic. How about if I do this technique? I'm able to hold it a lot more steady that way. Okay, I'll put my vertex here. And what if I draw an angle, and I'm going to draw up from this side. So I'm going in this direction with the arc that I'm going to use to label it. What if I draw an angle and I make sure to go further than 90 degrees? So again, I picture that 90 degrees, which with my eye I'm able to do a fairly good job. If I make sure that the angle is opening wider than that, now I have drawn another angle, and this is not an acute angle. This is an obtuse angle. So those are the angles that are greater than 90 degrees. Specifically, they're angles that are between 90 degrees and 180. So acute angles are between 0 degrees and 90, and then when we pass 90, we're drawing angles that are obtuse, so long as we go all the way up to 180 degrees, which of course is the straight angle. I think we have covered all that we have to do right now. And so the thing to do next is to start drawing them and measuring them. And I've been kind of avoiding using the protractor up until now, as you can tell, but I'm not going to avoid it anymore. For those of you who watched last week's lesson or the lesson the week before, you saw me trying not to use the protractor, but I kept on reaching for the protractor every now and then because it's just such a useful tool. I found myself using it, even though I was hoping to save it for this week's lesson. So, yes, I know the students have seen the protractor before, but now we're going to get into it. We're going to talk about the protractor in detail. We're going to spend a bit of time on the protractor. So we use a protractor to draw angles, but we also use it to measure angles. Most protractors look like this one, that it's half a circle, and you see two sets of numbers on it. And there are two sets of numbers for good reason. It is possible that you'll see other types of protractors. This one has a whole circle. might not be so easy to see because of the black with the black background, but it has the whole circle and it only has one set of numbers. It doesn't need a second set of numbers because of the fact that it shows the whole circle. That's convenient, but this type of protractor isn't as common. And I know that when you see an engineering ruler, it might have a sort of a protractor built inside the ruler, and that protractor also will go in a whole circle, and it's useful for the same reason that round one is. But since most students use this style half circle protractor, that's the one I put my emphasis on when I am teaching how to use it to draw and measure angles. So since we already have an angle here, let's measure it. How do I do that? There is a 0 dot on the protractor. I call it the 0 dot because I just don't know another name for it. But it's right here. It's in the middle of that flat side on the protractor. And I need the 0 dot to go on the vertex of the angle that I'm dealing with. That's important. It seems obvious, but it's important because this vertex A is what I'm working with right now, but I could have another point labeled B, and maybe I'm talking about an angle that has B as its vertex. So where I put the 0 dot of the protractor depends on which vertex I'm working with. Right now I'm working with vertex A, so I get the protractor lined up so that 0 dot is on the vertex that I'm using. And then we have the baseline. The baseline goes along that flat side of the protractor, and we need that to go on one of the lines that makes up our angle. So I'm choosing to use this line. I have my 0 dot on the vertex, and I have the baseline going along this line that I can call AB. But I actually had a choice. I could have instead put the 0 dot of the protractor on vertex A and had the baseline go on this arm instead. So with protractors, you have a choice. And that is important to know. Protractors are easy to use. Most students find them easy to use, but there can be a couple little hiccups along the way. And those hiccups have to do with the fact that I can line up my protractor like this, or I can line it like this. Line it up like this, I should say. If I'm lining it up like this, and I'm setting up my 0 dot properly, I'm using the right side of the protractor when I decide I'm going to draw this angle or measure this angle. And that means that I'm using this set of numbers on the inside. Why? Why am I using that set of numbers and not this one? Because when I'm drawing an angle or measuring an angle, I want to count up from 0. And the 0 is on the inner set of numbers. The outer set has a 180. So that's interesting. We have two sets of numbers because we have two sides of the protractor. If I line it up like this, like I did earlier, okay, I'm still using the protractor properly. The 0 dot is still on the vertex A that I'm using, and the baseline is going on this other arm. And again, if I want to measure or draw, I want to count up from 0, but on this, now I'm on the left side of the protractor. On the left side, the 0 is on the outer set of numbers. So if you're using the right side of the protractor, you will use the inner set of numbers if you're counting up from 0. If you're using the left side of the protractor, you use the outer set of numbers. And that's why it has to have two sets of numbers, because a protractor is designed to be used with its right side when we need to, or with its left side when we need to. Interesting. So let's measure this angle. Set up the 0 dot on the vertex, set up the baseline on the line segment AB, which I've decided I'm using. And then I count up from 0, which means I'm on the inner numbers, and I count all the way up until I get to this line. And I think that that line is happening right about 118. So I can label this angle as a 118 degree angle. I can refer to this as angle CAB or angle BAC, or sometimes you will see it described as angle A. So if it's angle A, the letter that we're giving is the vertex that we're using. But this notation to me is more clear, because when you have the three letters, the vertex you're using is the middle letter. So angle CAB, I can see it as being, okay, CAB. The A has to be in the middle, and it's in the middle, and that tells me what angle I'm using. But angle BAC is the same angle, it's just that I'm counting from here, BAC. Two appropriate, correct names for this angle. Notice how I don't have any correct name for the angle that involves the B or the C being in the middle. That would be incorrect because I need the vertex that I'm actually using to be the middle letter. I like this notation, it makes things clear. I'm going to erase that. Now, what should I do next? Okay, so that was an obtuse angle, so I erased the word obtuse. The obtuse angle is the angle between 90 and 180 degrees. Let's draw some more angles. To draw the angle, I need a baseline and I need to decide which vertex I'm using. So this time, I'm going to draw 90-degree angles. Now, I had one before, we talked about it a little bit. Now we're going to get into the 90-degree angle a little more, just to illustrate something. So what I'm going to do is I'm going to draw 4 baselines. There's one. Here's another one. I need more chalk. And I'm going to draw a third one over here. Try not to let the ruler slip around while I'm doing it. And a 4th baseline over here. That time the ruler slipped around a little bit. That's good. Okay, so I can draw the 90-degree angle 4 times. I'll just write 90 degrees here to remind us that we're drawing 90-degree angles right now. And notice the symbol for degrees, which is very useful notation to understand. Now, why am I doing this 4 times? Because I'm thinking of 4 different ways that I can approach the drawing of a 90-degree angle when given a baseline. So let's say, for all of these, I'm going to name them line segment AB, and I'm always putting the A on the left and the B on the right. I'm just trying to get organized here. But my assignment is draw a 90-degree angle. And I want to experiment and see, well, how many ways are there for me to approach a baseline like this AB, horizontal line, from my viewpoint, that is a horizontal line, and draw a 90-degree angle using this line segment as one of the lines in the angle. Now I will use the protractor, even though I think I'm pretty good at doing it by eye, or I could trace the corner of a sheet of paper or something. I'm into the protractor now. I'm going to use the protractor. What if I decide that A is my vertex that I'm using, and this AB is my baseline? And I decide, and I walk up to it and I hold the protractor above the baseline like that, which is, I guess, a natural way to approach a line with a protractor. Counting up from 0 means I'm using the inner set of numbers, remember that, and I'm going up to 90. I want a 90-degree angle, so I'm making a little mark where the 90 is. And then using any straight edge, I can use a ruler if I want. I can draw any straight edge, I can draw that. I have a 90-degree angle, which I can use this notation to indicate. I can name the vertex on the other line, not vertex, this point C on the other line, just because it makes it easier for me to give a name to this angle. And yet again, I have an angle, 90-degree angle that I can refer to as angle CAB or angle BAC. So everything that we've learned so far just applies here. But wait, what if I do the same thing with this one, but I'm walking up to the baseline and I just decide to hold the protractor like this? Is this wrong? No, it's not wrong. The 0 dot is still on vertex A. I've decided I'm using vertex A again for this one. And the baseline is going along the line that I'm starting with. And I want to count up from 0 to get to 90 degrees. I can count up using the outer set of numbers over here. 90 degrees, put a little mark. Get a straight edge. I'll call this C again, and I can use the same notation if I want, so I will this time. I have drawn a 90-degree angle. This is still correct. So the fact that the angle got drawn above the baseline here and below the baseline there doesn't matter. The instructions were draw a 90-degree angle. It didn't say draw a 90-degree angle above the baseline or below, so both of these are correct. And the protractor is designed to be flexible because you don't always want to draw up here. Sometimes you're in a situation where it's useful to draw down there below the baseline. So having a protractor that can allow you to do either is good. What if I use vertex B as my starting point, as the vertex of the angle? What if I use point B, I should say, as the vertex of the angle? Okay, I'm walking up to it and I'm going back to the old habit of having the protractor above the baseline. I line up my 0 dot on vertex B, it's going to be a vertex, and my baseline going along the line that I have to start with, and I'm going to count up from 0 to 90, which means this time I'm using the left side of the protractor. I'm using the outer set of numbers. I put a mark on 90, and then I get a straight edge. The edge of the protractor is useful as a straight edge sometimes, but other times I prefer to grab for the ruler. I'm going to put a point C here, label it, and this time instead of using that arc with 90 degrees as my notation, I'm putting this little square that also means I have a 90-degree angle. We have to be familiar with that because we're going to see it a lot. And I've drawn yet another correct 90-degree angle, but it doesn't look exactly like these other two, because this time I used vertex B. So over here I used vertex A and I drew above. Here I'm using vertex B and I'm drawing above. Over here I used vertex A and I drew below. And I guess in the last one, I better use vertex B and draw below. Is there room to do this? I don't really have the camera aimed at this perfectly, but it'll still work. Okay, so I'm approaching vertex B with the protractor held this way again. I'm getting my 0 dot on vertex B. I'm getting my baseline to go along the line that I'm starting with. I'm counting up from 0, so I'm using the inner numbers again. Up to 90, make a mark. I'm standing in an awkward position. Does the mark show? Just barely the mark shows on the little video screen. And then I draw a line. And I'm going to label that a point C over here again, and I'm going to use this notation again. So anytime we walk up to a line on a page and we need to draw a 90-degree angle, we have all these choices as to how we do it, as to which end of the line to use for a vertex, and whether to use the left side or right side of the protractor, whether to hold the protractor above the line that we're starting with or below it. We end up with all of these choices, and they're all correct. So there are a lot of different ways to correctly draw a 90-degree angle. The truth is, for any size angle, not just the 90-degree angles, there are a lot of different ways to draw them, and the protractor is designed to be flexible so that we can use it to do any of those drawings. So let's do some more angles and do something that's not quite so straightforward as a straight angle or a 90-degree angle. Let's draw some acute angles. Erase all of this. And I'll remind you, as I like to always do, that when you're learning math for a whole hour or sometimes even longer, every now and then you should stretch. And it doesn't hurt to have some water, especially if you're doing a lot of talking. This is fizzy water, root beer flavored fizzy water. Okay, let's draw some acute angles. So those two sets of numbers are useful. And once you realize why there are two sets of numbers, it stops being confusing to look at the protractor, and it just gives you some more power. The fact that you can hold the protractor like this if you want to, or like that if you want to, is useful. But all of those situations where I was drawing, I was starting with a horizontal line. The truth is, the reason we want it to be flexible is that a line can be going in any direction. So long as it's straight, it's a line. So I can draw my starting line without it being horizontal. And in fact, I think I'm going to draw one more 90-degree angle just to make that point. So I'm going to draw this tilty line. And it's not horizontal, it's not vertical, but it's a line. And it's a perfectly good line for me to start with to draw an angle. I'm going to name this point A, and I'll put a point B over here. And from point A, I'm going to draw a 90-degree angle. And the fact that the line's tilty this time just doesn't matter, because the tool is flexible and the tool still works. So I'm choosing to go up to the vertex A with the 0 dot of the protractor like this, make sure my baseline goes along the line I'm starting with. I can count up from 0 over here to 90, but I can even count up from 0 over there and still get to 90 And either way, I'm going to get to 90. That's interesting. 90 is interesting in that way. But let's just stay over here. Counting up from 0, that means I'm using the outer set of numbers. Put a line, get my baseline, draw the line. Don't really have to label a point over here, but I like to, so I'm labeling it C. And we have yet another 90-degree angle, angle CAB or BAC, or possibly, if you wish, angle A. Doesn't matter where the line is, which way it's pointing, and we can walk up to it with this tool and we can do this. That is useful. Now some acute angles. Let's just draw a few acute angles. We know an acute angle is between 0 and 90 degrees. So I'll write acute again. I'll give myself more chalk first. Let's do a few acute angles, not cute angles. Mocha's cute. Acute angles. I need some baselines. Let me draw, and again, the baselines don't have to be horizontal. I'll draw a horizontal one here, but then I'll draw another one that's not horizontal over here. I'll draw one that's actually vertical, or pretty close to vertical, over here, and then that one's tilted that way. How about I put one, I'm going to make sure this shows on the video rectangle. Put another one there. Angles are very flexible in terms of where you place them. So I have a bunch of baselines that I'm going to start with. And I want to draw some acute angles. So away with the ruler, let's get busy with the protractor. Between 0 and 90 degrees, how about 30 degrees? 30-degree angles happen a lot. Okay, which end of the line? I'm not even labeling A's, B's, and C's on these right now because I really don't have to. Which end of the line am I going to use to draw my angle? For my vertex, it could be this side or that side, either one. I'm going to use this side. And I want to draw a 30-degree angle. So I approach with the protractor. And as usual, I have a choice as to whether I put the protractor above or below. But I just go with my usual habit, which for me is usually to go with the protractor up above the baseline and get the 0 dot onto that end of the line. Make sure the baseline goes along the line. 30 degrees means I'm using the right side of my protractor, so I'm counting up from 0, that's the inner numbers this time, up to 30, make a mark. Get my straight edge, draw a line between that mark and the vertex, and I should label it. And we don't use the little square for anything except the 90-degree angle, so I'm putting the little arc, and I'm writing 30 degrees. So we can see there's a 30-degree angle. And it's an acute angle because it's between 0 and 90 degrees. Let's do another one. What else is between 0 and 90 degrees? Let's try and get closer to 90. How about 80? Let's draw an 80-degree angle. And I'm going to use this end of this line. And I'm going to hold the protractor like this. Now this whole above-below thing is starting to become more vague when we don't have lines that are very close to being horizontal. So I'm not even going to say above-below. I'm just going to say I'm approaching it this way. And then I get my 0 dot on the end of the line, I get the baseline on the line, and I'm going to count up from 0 to 80, which is here. That means I'm using the inner set of numbers. Make that little mark. Now some protractors you would be able to draw the line right away, but other protractors, the protractor gets in the way because there's a piece of plastic or wood in this case in between you and your drawing. So it's good to make that little mark so that you have a reference point, and then you can draw the line when you need it. And now I feel quite confident, because I was careful to put that dot in the right place, that I have just drawn an 80-degree angle. And yes, it is just a little smaller than a 90-degree angle, and it's kind of easy to see that by eye. Two acute angles. Let's do another one. How about 45? 45 degrees is another special angle that we see more often than some of the others in math. So let's do a 45-degree angle. Which end of this? I have to make sure. Okay, this whole little line I drew does fit in the video rectangle. I'm not going to draw down where we can't see it. I'm going to draw it up here. I'm going to use this end of the line as my vertex. I'm going to get my protractor, approach, not saying above or below too much, just approach it this way, so that the 0 dot of the protractor is on the end of the line, and the line goes along the baseline of the protractor. I want to count up from 0 to get to 45. That means using the outer set of numbers, because I'm over on the left side of the protractor right now. Up to 45, make a mark. There's my mark at 45. Get the baseline. And we have a 45-degree angle. Label it, and I'm done. What's a last sized angle to do just for fun? We got a rather large acute angle, almost 90. Let's do a really small acute angle with this one. Does that line, see, I can't see that line very well because of the camera being held by a clamp. And the clamp's in the way. So what I'm going to do is just to make sure, because I know this one fits, I'm just going to erase a bit of the bottom of the line and make sure it's going to fit. Let's draw an 8-degree angle. 8, quite small, quite close to 0. I'm going to draw it from the bottom. I'm going to therefore put the 0 dot of the protractor on that end of the line at the bottom. Going to make sure the baseline goes along the line. And I'm using the inner set of numbers because I'm over here on the left-right side of the protractor. Doesn't mean very much when it's aimed this way. So this side of the protractor, I'm using the inner set of numbers to count up from 0. And 8 is only not very far. It's like here. Yes. I'll even use the ruler for my straight edge because this is a little bit difficult to draw without it getting to be too smudgy. So let's get this lined up. Yeah, and then I'm going to make this line longer. The first one that I started with. I have room, so let's make it a little longer. Whoa, skinny little angle. Yes, an 8-degree angle. Now, how am I going to label it? Notice how I write the degree measurement inside the angle, but when you have an angle that skinny, it's not so easy to do. But I can put this arc really close to the vertex if I want. I can also put it further. Haha. And then if I write small enough, 8 degrees, I did it. I don't know how easy it is to see on the video screen, but there's an 8-degree angle. I managed it. So, protractor, very powerful tool for drawing angles. And we drew a whole bunch of acute angles. And it's fun. Drawing angles is fun. What about I draw a few obtuse angles? So I'm going to erase again. But first, let's wash the chalk dust out of my mouth so that I can talk. And I'll get quite a clean eraser cloth because this chalkboard wall has become quite smudgy. And I will erase all of these angles that I just worked so hard to draw so beautifully. Always sad when you draw something and then you have to erase it. And I'm going to draw some obtuse angles. Reminder, obtuse angles are between 90 and 180 degrees. Doesn't include 180. If I draw a 180-degree angle, I'm drawing a straight angle. It's no longer obtuse. And it doesn't include 90 either, because if I draw a 90-degree angle, I just drew a right angle. I drew a 90-degree angle. Right angle. Did I say that before? Did I forget to say a 90-degree angle is also called a right angle? Kind of important to point that out. Okay, let's draw some baselines. And again, I'm going to put the baselines at whatever angle instead of always trying to do horizontal lines because I don't want students to feel like their angles always should be drawn from lines that are horizontal, like you see when you have lined paper and you have it set right in front of you, because angles are independent of that. You can take that piece of lined paper and you can twirl it around any way you want with what's called in math a rotation. And you can still draw an angle on that line, no matter how you have it twirled. And the protractor allows us to do that. The protractor gives us so much flexibility. Draw another tilty line over here. And then I don't want to get too low on the chalkboard wall, so that one should be okay. And how about, put that one. There. Let's draw 4 obtuse angles. So, angles between 90 and 180, not including 90, not including 180. How about 95? Not much bigger than a 90-degree angle, but 95-degree angle. Let's do it. Which end do I want to start with? These instructions are so flexible. So my instruction said, draw an obtuse angle. That's it. It's not saying above or below the line. It's not saying use this as the vertex. So I can do whatever I want. I'm going to use this as the vertex, and I'm going to approach with the protractor held like this. 0 dot is the protractor on the vertex I'm using. Baseline going along the line I'm starting with. And I want to draw 95 degrees. I'm using this side of the protractor, so I'm using the outer set of numbers. I climb up those numbers until I get to 95, and that's a tricky one. If anyone's going to make a mistake with this, this is where it might happen, because the 95 is so close to where the 85 is. If I were counting up from this side, 95 would be right here. I'll even put dots. See, there are two 95s, depending on which side of the protractor I'm using, but I'm using this side of the protractor, so therefore, I'm erasing that one. That's the 95, that's the one I need. Straight edge. And I have a 95 degree angle. I can't use a little square for that. That's only for 90. So I draw an arc at 95 degrees. I did it. By eye, you should be able, I'm going to try and stand where you are and look at it. Yes, by eye, you should be able to tell that that's bigger than 90 degrees, but it's only a little bit bigger. So you can tell it's obtuse, but if you're not sure, you have to take a good look at the information you're given, because sometimes when we're doing math, sometimes we're giving angles and triangles where there's an angle that's quite close to 90, and we don't want to just jump to the conclusion that it must be 90, because that can lead us in the wrong direction in our math steps. So judging by eye, it's a useful thing to do, but if you're not sure, and if the difference matters, get your protractor and measure it. Okay, so there's an obtuse angle just slightly larger than 90 degrees. Let's do another obtuse angle that's way more than 90 degrees. So the largest obtuse angle would be 179 degrees, or I guess 179.999 degrees, but we won't get into decimals and rounding. We'll just say, oh, let's do 168 there. See, I sort of randomly made up the number I want. Big, almost a straight angle, but not quite. 168 degrees, let's do that. I'm going to use this, make sure this will fit. Okay, I'm going to use this end of the line for my vertex. I'm going to approach with the protractor over here. I'm doing the usual thing. So many of these steps keep on being the same way every time. I'm going to make the 0 dot of the protractor go onto the vertex I'm using, and the baseline of the protractor go along the line that I'm using to draw from. And 168, I'm over here on this side of the protractor, so I'm counting up from 0. That's the outer numbers. And I'm going all the way over here. Oh, quite far there. 168 is way over there. Let's get the straight edge. Wow. You can tell it's not a straight angle, but it's getting pretty close to a straight angle. And I have to label it. And whether I put the arc over here or down there, it would be easy to make a mistake with this one. But it is obtuse. It's between 90 and 180. It's not bigger than 180, so I'm going to put the arc here, and I'm labeling it. I can do it. I can do any angle I want with this tool and with these flexible instructions. I'll erase that because I don't need it anymore. I have this one. Let's do some more middle of the road obtuse angles. So not really close to 90 or really close to 168. Is there one that's common? We know that the 30 is common, the 45 is common, the 60 degree angle, very common in math situations. But what about in obtuse angles? What's common? 135 degrees is a very common obtuse angle to have to deal with. I'm going to do one, so I'll write 135 degrees there just so I remember what I'm doing. Let me see, I think I'll use this vertex over here, and I'm going to hold the protractor up here because I don't want to draw right off of the video rectangle. So 0 dot of protractor on vertex I'm using, baseline of protractor going along the line I'm using, counting up to 135 from 0 means I'm using the outside set of numbers, and 135 is there. Still a pretty wide open angle, but not quite as much as that one, as you can see by the measurement and by eye. It works. 135 degree angle. Why is 135 common? Because if you have a 90, which is a really common one, and you add a 45-degree angle, which is also a really common one, 90 plus 45 is 135, and that's the reason why we see this a little bit more often than a lot of the other obtuse angles that are possible. Because any number between 91 through 179 is an obtuse angle. They're all good angles. But we'll see this one more often than some of the others, that's all. Let's draw one more obtuse angle, and I'll use the same sort of strategy to decide the size I should make it. Another angle of a size that you tend to see more often than the others is going to be 120 degrees. See that quite a lot for a very similar reason to why you see 135 degrees. Let's just come right out and say it. 90, that very common right angle, 90 added to 30, which is another really common one. 90 plus 30 is 120. So we see 120 degree angles quite a lot. I don't want to try and draw it over here because it clutter up against this one. So I'll use that end of the line for my vertex. 0 dot of protractor on vertex I'm using. Baseline of protractor on line that I'm starting with. Counting up from 0 means outer set of numbers. This time I go up to 120 and I make a mark. Oh, I'm really getting my stretching in this lesson. Drawing angles on a chalkboard wall is a really good way to stretch. Okay, and I will label it. 120 degrees. That was fun. So I spent an awful lot of time drawing angles because I wanted to show all the different things that can happen. I wanted to show all the flexibility of this tool and how it doesn't matter. It doesn't matter how many different ways there are to do it because we have the right tool to do anything we want or anything we need to do. So what I want to do next is measure some angles. Now I'm not going to measure these because we drew them. We already know what the measures are going to be. It's not going to be a surprise. So what I'm going to do is draw some angles where I don't draw them to a set degree. I'm just going to draw two lines that connect, and then we'll measure the angle that the lines form between them. Erase. Let's measure. Now, measuring involves using the protractor. And if anyone's ever confused about measuring angles with a protractor, they're confused about the same things as people who are confused about drawing angles with a protractor, which means that you're already no longer confused. We're repeating something that we just talked about a lot, which is there are two sets of numbers, and they are there for the reason that it gives us a lot of flexibility when we're using the protractor, so that no matter how the line is tilted, which end we approach, how we hold the protractor when we approach, we're going to be able to do it. I need to draw some angles without knowing their measures, so I'm putting down the protractor, and I want to surprise myself. I'm going to draw some angles. There. There's one. How about, I'll do that, and then I'll do that. Not quite a horizontal line. It's a little messy. Okay. I'll measure those two, but I'm going to draw 4. I have room for 4. Those are both acute. Let's draw an angle that is obtuse. Draw another obtuse angle that's bigger. Now, if I happen to get a measure that's exactly the same as one of the ones that I just drew, it's coincidence. And you know it is because I just randomly walked up and drew lines to do this. I wasn't making sure to get any type of measure. I can still look at it and kind of estimate. I could estimate, this looks like I think it's bigger than 30, but I'm not really sure. But if it's bigger than 30, it's not much bigger than 30. This one's pretty close to 45. I can do that, certainly. This one, maybe it's 160 or 155. It can be fun to try to do that, but what we want to do is make sure we know how to use the tool for measuring. So I'm back to the protractor. Okay, let's start with this one. With measuring, just like with drawing, we have choices. We can hold the baseline of the protractor, there's my vertex. I don't really have much choice about what to use as a vertex here. We can hold the baseline of the protractor with this line or with that line. We have a choice. But if I did it with this line over here, with the protractor pointed that way, it would be quite awkward. This protractor is not designed to do that. Maybe that other round one would be useful. So if I want to use that line, I need to twirl the protractor around like this. So let's say I do that. Okay. So the 0 dot's on the vertex. The baseline's on one of the two arms, one of the two lines that makes up my angle. That's all allowed. And I'm counting up from 0, which in this case means I am using the outer set of numbers. I wonder how well those could be seen in this little tiny video screen. So I'm going to start this over again, but first I'm going to move over here and see if I can get it to focus. So we can see the two sets of numbers. And I want to start by counting up from 0, so this time I'm using the outer set of numbers. There we go. 0 dot baseline. Always make sure that you arrange both of those things, because you will not get the right measurement, either drawing or measuring, if you don't have your 0 dot in the right place, if you don't have your baseline. And then counting up from 0, outer set of numbers, I see that is a 35, maybe a 36. I'll call it a 35-degree angle, so I want to say that with my label, 35 degrees. I was guessing it was a little more than 30. I feel like my estimate wasn't too bad. Didn't actually say 35 though, did I? So the protractor has more confidence than my estimate. Okay, this one I was guessing might be around 45. Let's see. I can approach it like this, or like that, whichever way I prefer. I'm going to do it like this, just to prove it, because I think this would be the less frequently chosen choice. So let's go ahead and do that, because I know that it works either way. 0 dot on vertex, baseline on the line that I chose to use. Counting up from 0 means the outer set of numbers again this time. And no, it's not 45, it's 50. This is a, hey, get a really beautiful arc by tracing the edge of the protractor there. I never really thought of that, actually. 50 degrees. So I guessed 45, I was fairly close. There's a couple of acute angles that I was able to measure with a protractor. Now I'm going to measure this obtuse angle with the protractor. I choose to approach it like this. Again, I have choices, but this is the choice I'm making. 0 dot, baseline. 0 dot on vertex, baseline on the line I chose to use. Counting up from 0, up, it's the outer set of numbers again. And that's, 100 and, I forgot to estimate this one before. 118 degrees, no, 108 degrees. 108 degrees. Okay, now this one. I keep on using, and these three I just did, I think all three of them I used the outer set of numbers, so this time I'm going to make myself use the inner set of numbers. There's my vertex. If I do it like this, okay, if I do it like this, 0 dot on vertex, baseline on line I'm using, no, that's the outer set of numbers, so that's not what I wanted to do. So I'm instead changing my mind and I'm doing it like this. 0 dot on vertex, baseline on the line I'm choosing to use. Counting up from 0 this time means using the inner set of numbers. And I have to get my hand out of the way. Using the inner set of numbers, 146 degrees. See if I can trace that thing and have it look good. Yeah, it's pretty good. 146 degrees. I did it. I'm going to check the time. Getting pretty low on time for this lesson. I like this though. All the different 90-degree angles, all the different acute angles, all the different obtuse angles, the flexibility of walking up to the piece of paper or the chalkboard wall with this thing, and how much you can do with this thing if you know how to use it. That's cool. I'm looking at some notes that I wrote over here before, and I think I've covered a lot of stuff. So what I'm going to do with the last few minutes is I'm going to just briefly introduce some topics that we're going to talk about a lot more in the next lesson, which are the idea of adjacent angles and vertical angles, complementary angles, supplementary angles. Not going to get into it with a whole lot of questions because that is for next week, but I'm just going to introduce the topic a little bit. Now, one of the things, I'm going to start by keeping this 50-degree angle and erasing the other three. I'm going to point out something that's happened a lot. Pretty much everything I can think of in today's lesson and the last 2 weeks' lessons, that we kept on having so many angles, but usually we're dealing with only one angle at a time. But the truth is, anytime you have an angle, you can add another line and you can create more angles. So I'm going to create another angle. Now this is still 50, this. So as I create the other angle, I'm not extending this arc and still calling it 50, no. If I draw another line over here, okay, I just created another angle, which I'm going to put a different arc. I'm choosing to put the arc further away from the vertex just to make sure it doesn't blend in too much with that one. And we can see what we have. Now we have two angles. We have the 50-degree angle and we have this new one. And of course I could measure the new one. But the point is, these are adjacent angles. When you have two angles that are beside each other, but beside each other could mean a lot of different things. So here, without even using a ruler, I could say, well, here, these two angles are beside each other. It's not the same thing though, is it? So two angles that are beside each other that share a common side, which these ones don't, so I'm erasing that. This side here, let's give it some names. I'll call this vertex A, and I'll put a point B, and a point C, and a point D on this drawing. This line AC is part of angle BAC. There, the notation becomes useful. There's angle BAC. We know it's 50 degrees. We already knew that. But we also have this angle here, CAD. And we don't know its degree measure yet, because we can measure that. So I'll make an equal sign and make space to give the measurement of it. They're adjacent angles because they share side AC. And you see the AC here, and you see the CA there, and it helps us to see what we're talking about. Adjacent angles have a side in common. But when I created angle CAD, when I added that smaller angle down here, was I turning a drawing with one angle into a drawing with two angles? Yes. But can I say I was creating a drawing with three angles? Yes. The thing about adding an extra angle to a drawing is it's really easy to add a line, and it means you're adding more than one extra angle. So I didn't really leave very much room for it. I am going to measure this, and I'm going to write its measurement in here. So measuring means I need my protractor. So I approach it any way I want. We all know there's so many different ways of doing this. I'm not going to talk about it anymore. 0 dot baseline there. This is the way I'm doing it, and that is a 20-degree angle. Inside set of numbers, 20 degrees. So I'm going to put the 20-degree label in there so I keep some room. But what I did was I took my 50-degree angle, and by adding one line, I was able to add to the drawing a second 20-degree angle. But I also created this bigger angle, and I would have to call that, let me finish that, I would have to call that angle BAD, and I don't think it's a bad angle, it just happens to have the name BAD, and that angle BAD would have to be 50 plus 20, it would have to be 70 degrees, wouldn't it? So I have a way of figuring out how big it is because of the situation by adding the 50 and the 20. But I also have another way of figuring out how big it is by using my protractor. 0 dot baseline, counting up from 0, 70 degrees, yes. 70 degrees. Two different ways of finding out that angle BAD is 70 degrees. And I'm taking advantage of the fact that these are adjacent angles. Well, that these two are adjacent angles. And when I created them, in doing so, I created this third angle. Neat. I think it's neat. How much time is left? So adjacent angles, that is a cool geometry thing, but you have to have a word for it. So we have to know the word adjacent. But there are other words I want to talk about, and I'm going to talk about vertical angles next, so I need to erase. No longer using this beautiful angle BAC that came in so handy in so many different ways. I'm going to draw vertical angles now. How do I draw vertical angles? What's the definition of vertical angles? I have it written down somewhere. I'm going to make sure that I don't get it wrong by reading it. Okay, so you can create vertical angles with two intersecting lines. So I'm not really talking about line segments so much. I'm going to draw parts of two lines that will intersect. So here's a line, and now I'm going to draw another line that intersects it. Notice how I'm not just drawing to a vertex and then drawing the other arm. I'm drawing two lines that cross each other and keep going. But in doing so, I created four angles. Let's give these points names. C, A, T, and P, D there. I'm just trying to have fun with the naming of the angles. Now, it gets confusing because when you draw the two lines, you create four angles. And if you start thinking too hard, you start finding more angles in there, and then you're confusing yourself. You don't want to get confused. Let's just think about how, when we did this, one of the angles we created was this one. So I'm going to mark it so we know which one we're talking about. And I want to measure it. Approaching any which way I want, any way that's allowed by the way these protractors work, and this is one of the ways that's allowed, I can see that's a 60-degree angle. I measured it. Vertical angles, the opposite angles have to be equal. So because I know what vertical angles are, which can only be made if both lines are straight, they intersect. So I make an angle over here, and its opposite angle, vertically opposite if you will, also has to be 60 degrees. I know that because I know what a vertical angle is. But I can also measure it. And there's my protractor baseline 60 degrees. I made angle CAT and angle PAD, and they're both equal to 60 degrees because they're opposite to each other in a set of vertical angles. There's also this one. I'll draw the arc bigger. PAC, and this one, TAD. Angle, and I'm running out of time, so I'm going to stop very soon. PAC and angle TAD. I'm changing this from PAC to CAP. Just because I'm having fun making words. TAD, cap, pad, cat. Okay, that's a little messy. Now, the four of them add up to 360 degrees because they add up to a circle. That's cool. I could probably figure out the remaining angles, these two, their measures, without having to measure with the protractor. But I'm just going to stick with the idea of vertical angles. If cat and pad are vertical angles, they're opposite. Well, these two are also opposite to each other. So if I measure one, it should give me the same measure as the other. Let's measure. If I measure this, counting up from 0, it's 120 degrees. Well, that was cap. That means because they are opposite in a set of vertical angles, TAD will also be 120 degrees, and I know that without having to actually measure it, but I'm still going to measure it. Yep, it's 120. May as well label it. Okay, so vertical angles and adjacent angles are important. Really, my focus right now, just introducing them briefly, is the lingo, the language, the terminology. Vertical angles, adjacent angles, very useful. This is extremely useful because we use, sorry, I pointed the wrong one. Adjacent angles, adjacent is extremely useful. That's the one I want to focus on because we use that a lot, because whenever we start putting more than one angle into a drawing, we often will have angles that are adjacent, and having that word helps us to explain what we're talking about. With that though, I'm going to stop. I'm getting into complementary and supplementary angles because we're going to get into them a lot next week, and we're going to get far more into vertical angles and adjacent angles next week. And that means it's time to wrap up this lesson. Boy, that hour went by fast. It's an hour and 30 seconds, so I got overtime. There's a very well-behaved dog over there who's going to say goodbye, and then we are finished with our lesson. Oh. Someone wants her supper, and she's earned it by behaving really well for the past hour. Oh, she's not really that comfortable. Okay, you feel secure now, dog? All right, so thank you very much for being here. It was fun teaching you as usual, and I will see you next time.